Hi, everyone. Welcome to Mitigating LLM Risk in Insurance, Chatbots, and Data Collection. I'm Bernice Herman. I'm a senior data scientist at YLabs and really excited to dig into this topic for the next hour. You'll see on the bottom right here some links to YLabs to sign up for free. We'll actually be using the YLabs platform at the end of the session today. So go ahead and do that, ylabs.ai/free. Lan Kit GitHub. So we'll be using Lan Kit. If you want to check out the open source project, feel free to look at that. And then finally, the YLabs Slack group. So if you want to keep in contact, I'll put these links up again at the end. Okay. There we go. So a little bit of introduction to myself. I am a senior data scientist at YLabs and have been here since the very beginning of the company. My role in YLabs is very oriented towards statistics and machine learning. So we'll talk a little bit about how YLabs is structured and what it does. But largely my role is focused on these two sort of areas. So on the left, we have our open source packages, ylogs and Lan Kit. And both of those are really oriented towards gathering telemetry in machine learning data for later observability and monitoring purposes. There's a lot of statistics that goes into this. This is really a practice in calculating sufficient statistics, doing this as efficiently as possible, because we actually rely on summary statistics of your data. We don't ingest your raw data. And so as a result, there's lots of interesting statistics to get this down very, very quickly and efficiently. And then the second half is on the monitoring and anomaly detection algorithm side. So inside of the YLabs observability platform, once you've used these open source tools and analyzed your data and sent over some of that high-level summary statistic data, we then can look at this over time and find trends and visualize. So I spend a lot of time thinking about monitoring algorithms and finding anomalies in that data. Okay, so finally, a last bit about me here. So in addition to my role at YLabs, I am a research scientist at the University of Washington in Seattle. And my research there is about evaluation metrics in machine learning. So I'm very, very passionate about how do we understand whether or not these models work, mostly in very realistic settings, like production settings that we focus on at YLabs. And then finally, I don't normally include this in my slides, but I think it's kind of relevant here for our insurance series. So formerly, I studied actuarial and financial math at the University of Michigan. So I am a big fan of insurance, actually, since I've been really young, even though I'm not specifically focused on insurance now, though we do have a number of customers in insurance where I get to dabble back in. Okay, so this is our agenda for today, and it's pretty packed. What I'd like to do is talk a little bit through just, I think, 8 insurance use cases. They are not meant to represent all kind of use cases for AI and insurance, but just something to kind of get you thinking about different use cases that we've seen at YLabs, and different use cases that might be interesting to consider when we go on to the next section. And the next section is monitoring production AI systems at scale. So this will be a mix of kind of general production AI advice and insurance-specific insights with a number of different insights. And we'll kind of go into a different best practice and then talk about them in detail for quite a few of them. And then finally, we have 2 use cases. So the first use case we're going to dive into a little bit deeper. This is generating text with question answering customer chatbots. So something that if you're interested in LLMs, is a very common example that you see, this sort of idea of if our customers are discussing with the chatbot, how can we make sure that those aren't hallucinating, that they're acting in the way that we'd like? And then finally, legal entity extraction. So while the chatbot is very much reading text and generating text, there's a lot of different applications that produce other input. So in the entity extraction, you often will take as input text. So maybe it's a form, maybe it's a contract. I think we have some letters from attorneys in our case, and then extracting out tabular data. So extracting out numbers, addresses, this sort of thing. Apologies, let me turn this off. Okay. Cool. So that's our agenda. Let's go forward. So into our insurance use cases. I'm very curious for folks who are attending to type in your own use cases that I've missed or things that are interesting to you. These are the 8 that I chose to highlight. So one is claims processing. So extracting data and interpreting the text, the numbers, any of the contents of a claims form. And you can do this for a number of different purposes. For example, maybe you want to ensure that all of the needed information is submitted, that the address is valid, that sort of thing, that every form is filled out and in a meaningful way, right? So it's quite easy to check that there are indeed characters in a form if it's a digital form, but it's much harder to check that the answer is actually given, right? That there's a full description of the damage or whatever the form may have. Okay. The second one is contract and report creation. So in the insurance industry, there seems to be a lot of not only reading of text and reading of forms, but the creation of contracts and the creation of reports, the creation of letters that go out to customers. And so you certainly can explore using LLMs and AI to generate documents and reports, especially if they are pretty structured and templated, or otherwise with prompts. So still some human work to generate those prompts in the specialized case, but still very helpful to speed up the process, the human process of creating reports. Okay, so next are chatbots and smart agents. So conversational LLM applications where, for example, a customer after getting into a crash or something like this can open a chatbot and start to communicate with the bot. Certainly saves a lot of customer service time and can resolve and triage customer questions and initial claims processes, right? So I think in all of these examples, we will have a mix, right? Like, so these are already processes that are often done by humans, and thinking about these use cases as maybe not 100% automating away humans, but triaging and being able to find those simple examples and get those out of the way, and effectively passing on the ones that need to be passed on because they're more complex, is a pattern that you'll see here. The next one is fraud detection. So pretty standard across many sectors and industries, but detecting false or inappropriate submissions to various documents or processes, right? Typically when we think of fraud detection, we may think of just a financial transaction, but insurance has kind of a lot of text that's involved as well. So LLMs are particularly interesting in the insurance sector for this. Next, claims routing and triage. So instead of the customer service example, having incoming claim forms be routed to the appropriate next steps or escalated when needed. Then there's some more advanced things there that we might see. So computer vision damage assessment. So there are a couple of companies that are exploring in the space of using computer vision to verify damage to property that's sent via image or video. Sales and customer service training. So in the case that we have recordings of or transcripts from customer service calls, you can use LLMs and AI to provide coaching and suggestions either in real time or after the call to improve transactions and to train your customer service staff. And then finally, underwriting and pricing. So this is, certainly much more advanced and certainly not solely LLM, but considering creating policies and determining pricing, potentially highly personalized pricing using AI. I think this is something that many people in the sector are thinking about and considering and exploring. Okay. So I am going to stop between the sections and check for questions. I don't see any yet. One thing I will say that I missed is I find the insurance sector really fascinating for the use cases that are there. Often what I see is that a company or an organization may have a number of use cases for LLMs that they are exploring, but many of those use cases are brand new problems to solve that they haven't solved before. And that means that they often don't have labeled data. Insurance is really interesting because I think many of these very promising use cases and very kind of, AI forward use cases are problems that are having to be solved now by humans. So it's much more of an automation process. And that just gives so many advantages to the adoption of LLMs and AI. Because we do have labeled data, we do have ways of monitoring and ways of evaluating these systems using realistic data that your business actually produces, as opposed to kind of toy data sets or collected data sets from the internet. So that's all I'll say on that topic. I think what we can do now is move on to the next section, unless we get more questions. And this is monitoring production LLM systems at scale. So this is where I will give a number of best practices related to monitoring production AI systems broadly, but then focusing in on some tips for LLMs, and some of those tips being kind of specific to the insurance sector as well. Okay, so the first thing that I will say is that monitoring and observability are just as critical as evaluation and production. Sometimes it is not clear the differences between evaluation, monitoring, and observability. So let's talk a little bit about that. So evaluation, I think at a high level can be thought about as determining if and which or what issues are occurring. So evaluation is something that every data scientist learns about pretty quickly. And you often need labeled data. If you're doing some sort of supervised evaluation, you'll have some labeled data, some test data, and you can make a number of checks, right? You can see the accuracy percentage, precision, recall, a number of different metrics, but then more advanced things like interpretability and other analyses. But this is only part of the story. This makes a lot of sense. Oops, I guess my slides are in a slightly different order than I expected here. This makes a lot of sense on static experimental data. So when we have a static training data set that is split into train, validation, and tests, this is the process that we kind of expect to see. You can use this on future data sets, but the processes that we've learned and kind of the experiments that we're used to doing are really tailored towards static data. So the next one is monitoring. So this takes one step beyond the static data and starts to introduce time. So monitoring, I would summarize at a very high level, is determining when issues are occurring in your system. So we see here a number of alerts over time. This is actually in the YLabs platform, where the drift of a particular feature, loss output, has increased and is beyond maybe a static threshold that was set there. We don't just have static thresholds. You certainly can use a number of dynamic thresholds as well, where maybe we would have alerted the first time, but our confidence interval would have grown to kind of accept this higher value Hellinger distance over time. And so when we think about monitoring, now we're moving to this kind of production dynamic data. And the other thing to note is that it is about change, it's about difference often. And this is really beneficial in kind of real life settings and production settings because it does not require ground truth. So you see here in the picture here, I have a couple of days that may have some ground truth data, just represented by this little darker rectangle at the bottom of each day, but it's not necessary. And I think the insurance sector is really interesting for kind of the presence or lack of presence of ground truth. There are certainly some use cases that naturally will produce labels. Normally it doesn't happen right away, but you'll get some labels in ground truth. And then many other cases where unless you've kind of invested in collecting data from like having crowdsourcers or having employees go and manually label data, you're not going to get ground truth. So you have to be careful to choose solutions that will adapt to both and work in both situations. So that's monitoring, all focused on change, often over time. And then finally, we have observability. So this is about determining how and where in the system issues are occurring. So this is a kind of a busy diagram that I've taken from a paper. But I think this thinking about your system overall and understanding, well, not only that an issue has occurred, but where in that system has that issue occurred is helpful for the actual process of resolving those issues. I think there are many cases where starting with monitoring, where you know that an issue has occurred, can help, right? If you know what date or you know what time that this has happened, you may be able to pair this back to a change in your code or some change in the system. But being able to observe where in your system this issue is likely to have occurred is much better. And this is why we at YLabs always talk about observability. Like this is really the goal that we have for ourselves. Okay, so on that observability point is my next kind of best practice. And this is collect telemetry at multiple points in the AI systems process for improved observability. So this is one thing that I think when people start to explore monitoring is that they rightfully so think about collecting information at the input of their model and the output of their model, or maybe just the outputs of their model. And they use time to kind of understand where issues are happening. But we've built ylogs, which is our telemetry agent. I'll talk a little bit about that, to be very lightweight so that you can put it multiple places throughout your process. So if you have an application, maybe there are 5 or 6 different places throughout the process of an application where you want to capture data, some statistics about the data that's passing through. And differences between those will not only help you to pinpoint when an issue occurred, but where within the process an issue occurred. And there are other options like traces and things like this. But this sort of adding checkpoints across the application is really helpful. And I think particularly important in the insurance sector, where there are often problems that have a lot of components. So for example, you may be doing some sort of claim form processing of actual pictures or PDFs of forms. And so now you have multiple steps. You have to do character recognition. So you have the OCR step, and you would want to track telemetry from before and after that OCR step. You want to track telemetry between that and your cleaning step, and so on and so on. So there's so many different components, and in a lot of these use cases, that really thinking about intermediate checkpoints for telemetry is important. Okay, so next is a big one, and this is privacy. So privacy is critical, as I'm sure you know, in insurance and many, many other places. But I think the environment about data sharing with outside vendors is kind of changing. And one reason for this is LLMs. So there are a number of great open source LLMs, Llama, Alpaca, so on. And there are also very many publicly discussed, well-known third-party LLMs, so ChatGPT, et cetera. And I think the adoption of these kind of outside proprietary LLMs has been really surprising and changing over time and shifting over time. And so it's something to really think about as far as where your organization, like what your organization can share and what sort of structure you're going to set up for this. And it's not quite as black and white as we can't use any outside tools. But privacy is very, very important to us at yLabs and built in kind of ground up to our approach. So let me talk a little bit about how our approach works. On the left here, you'll see different types of data that can be passed in. So we have model prediction data, training data, batch data, or streaming data, something like Kafka. All of these data can be passed in to our ylogs agent, and that is where we collect a bunch of very important statistics about the data. So distributional information, missing data, summary statistics, data lifecycle events, whether or not there's missing things like that. And we actually only keep the high-level statistics, the metadata about the data that has been passed through, not the data itself, not the raw data. So how does this work? So this kind of orange side of things gets downloaded and deployed onto your machines. So wherever this data is being processed, wherever it's being passed through, so you can calculate those statistics. It's very, very lightweight, very intentionally so, and very advanced kind of statistically to do some interesting things we'll talk about in a little bit. But the reason that this is so different is unlike many other solutions, you'll never have to send raw data outside of your environment, right? And that can be, crucial for highly regulated areas like insurance and others. Then we can use this kind of high-level aggregate statistics on the observability platform to now find trends over time, detect issues, monitor kind of high-level trends over time, and then make pointers back to specific subsets of that data that is likely to contain issues. So if we have some sort of alert, then we can point back and say, it is on this subset of data with maybe this section of data at this particular location, if we've integrated that way, to tell us where the data scientists can go back and find that raw data back on your machine if you've decided to store it, which I find to be often the case in insurance. And then at the final on the right, there are many, many things to kind of make this more actionable. So reports and dashboards, alerts and notifications. So instead of having to watch this every day or multiple times a day, right, setting up alerts and thresholds over which, when it triggers, it emails or PagerDuty or sends a notification to the relevant team. And then many triggers and workflows. So as far as even kind of if you have certain sorts of distribution drift, maybe you want to retrain your model, or maybe you want to roll back any changes to the model if they happen immediately after some push and certain drift happens or certain events happen. All of these things are really important, I think, and done in a privacy first way, which is the key. This is just another picture to see that there are many things that you can still get out of this. So there's so much wealth of data from this aggregate statistics that you find that not only is the raw data, kind of a privacy concern and something that we don't take in and we're not set up to take in for that reason, but it's not really necessary for most of the work that we do. Okay, on to my next best practice, and this is take a data-centric AI approach, not a model-centric AI approach. So for those who are not familiar, data-centric AI emphasizes kind of iterating on data quality and the data set that is used, instead of focusing on model architecture and kind of a strictly better model. And I find in general that this provides a lot of results, but certainly in a place that has, like a sector that has data available, like the insurance industry, and more importantly, has a lot of human processes in collecting that data, right? So we know that there's going to be noise and missing values and error in the data that is collected, and focusing on cleaning that data as opposed to, for example, upgrading your LLM to the latest and greatest, or that trying to squeeze out performance that way is often the way to go. And this sort of philosophy is data-centric AI. So this is a list of example issues that we've seen in production AI systems. There are many. I won't read them all out here, but things like computational instability, environment production, experiment and production environment mismatch, right? So if you're experimenting on a model, but you throw it over to a different team to put this in production, there may be many differences. Latency issues, but lots of other issues such as accuracy, improving on one segment of your data, but regressing on others. Outliers predicted incorrectly. Bias in your data. We'll actually talk a little bit more about that. Overfitting on your training or test. Concept drift. So the relationship between two things changing over time. COVID's a big example of that for many sectors. Poor performance on outliers, so many different things. And many of the production issues that we've encountered are effectively data issues. So they can either be determined by or a result of some sort of quality issue in the data. And this is just a motivation to really focus on that data as opposed to the model. Okay. My next best practice, processing across all data doesn't scale. So keep your data in an analysis ready format. So this is where we're going to start talking about ylogs and why we've built it. It's an open source tool, but why we've built it and why this is important, even in a place where we have probably stored all of our data for some time. So you may have stored all of your data, but the problem is analysis. So when you have a large amount of data and you are looking for issues or trying to root cause an issue that's present, what you need to do is now analyze, these millions of rows of data. And storing it may be okay, but loading that data and analyzing it every time that we're trying to find trends in the data is just unreasonable. It's too expensive, both computationally and cost-wise. So there's really three options that I see for scaling this data analysis and monitoring. So one is sampling your data set. So what you can do is store a random sample of your data set, just kind of in the form that we normally see it. So something like this. These are just rows of a CSV file on the same format that you might see this data otherwise. But we take, let's say, 5% or 1% or 0.5% of the data and store this in a separate place that is easier for your data scientists to analyze. There's a lot of benefits of storing this in this way. It's a format that data scientists are used to. It's highly flexible. You can change the percentage that you sample very quickly. You can merge them together. It works for batch or streaming data, but it actually has a lot of problems, and we'll talk a little bit about those in a bit. The other two ways of analyzing at scale are about profiling your data. So what is profiling? Profiling is the act of reviewing and analyzing data sets to understand their structure or information. That act often done algorithmically by a computer. And data profiles can include the following. So a collection of descriptive statistics, maybe the mean, median, certain quantiles of the data. It can identify different data structures, types, or patterns. Maybe data profiling will note the overall data type or the distribution of data types of your data. It can categorize data sets, create descriptions, do more advanced things. So one approach to thinking about analysis at scale is to do some sort of static profiling of your data. So what this might mean is every day, when data has been passed into our system, we might do a end of the day calculation of the mean, the standard deviation, the quantiles, accuracy, precision, recall, any performance stuff that we have for the data that was passed in. And this can be helpful to very quickly get to analysis on long-term trends. It's fast access to these metrics, right? So if you go back and say, I would love to know the mean of the data from January 1st, very easy to access as opposed to having to download a full database of data and calculate some average over that. Low storage size, right? So this is very tiny to store and nice to hold in addition to the raw data held somewhere else. And then actual metrics on a single batch. So these are 100% accurate for that day. But there are some cons, and this is why we don't support static profiling. It requires metric pre-selection. So if I decide that I want to now start calculating a different metric, I can't really do that historically if I've only stored this fixed set and thrown away the data. And then the other one is that it's not mergeable. So we'll talk a little bit about mergeability. So you might want to answer questions such as, what's the estimated value of some new metric that I've come up? Maybe now I want to, in addition to F1 score, what I normally use, I want to start using some other special metric. Well, I can't really go into prior data and calculate that metric with the static approach. I may want to combine sets of data. What's the overlap of data in this set? What's the relative rank of a value on last year's data? What's the drift between two data sets? All of these things actually require a little bit more advanced profiling technique. And that's what we think about at YLabs. So our approach for that is sketch-based profiling. So data sketches is a technique that came out of the databases and theoretical computer science world, still actively being worked on. But it has kind of the best of both worlds here. So it has this mergeability, it has fast access to metrics, it's highly flexible. You can go back and change metrics, although there is some pre-selection that you want to do. And built on kind of peer-reviewed algorithms that really focus on statistical error and making sure we can estimate very well. Okay. And so we've wrapped our work in doing data profiling specifically for machine learning data and telemetry that can be helpful for monitoring in our open source package called ylogs. So ylogs is very simple. We'll use it in a little bit in our demo, but all you have to do is after importing, just say y.log, pass on your data, and all of this statistical calculation is done on the data that you've passed through. And again, ylogs is open source and meant to be kind of an agent. So when you are doing your machine learning or doing some other analysis of your database or anything like this, you can run ylogs over the data that you're processing for other reasons, and capture those statistics at that point in time. Creates a very small package with a number of these summary statistics that are important, and distributional information that are important. And then that can be passed on to analyze over time. Okay, so that was a big one. Now let's go on to the next tip here, and that's make sure to capture the effects of important and rare events. So this speaks a little bit to the first way of summarizing that I suggested, but it has some issues, and that's sampling. We actually did some analysis of data sampling versus profiling by comparing error on simple common statistical distributions. So this is a little bit of the experimental procedure, and these are some of the results, right? So the main point is that when we sample our data, so let's say we take 1% of our data, this can help us to uncover things like the mean, the median, perhaps, depending on the volume of data that we have. But it's very, very difficult to capture actually the things that we might want. And that's those tail events, those rare events that are in our data that may be causing issues. So for example, if there's some phenomenon that only occurs 1% of the time in our data or 3% of the time in our data, and we've captured 1% of our data, we are unlikely to have captured enough of this issue to really diagnose and understand it. And that's not a problem that we have with the data sketching approach. So the data sketching approach, you can do all sorts of things to determine where in the distribution are you hoping to capture information? What sort of error tolerance do you have? And we want to be as precise as we can across everything, of course, but we really do want to understand those kind of tail events, the P95, the P 9999, right? And so being able to do that makes sampling kind of just not work when you have rare events. And the other thing that this gives us, the other thing that data sketching gives us, is the ability to merge data together. So this is most important in cases where we have distributed systems, or that we're trying to analyze things over time. So in a distributed system, I might have some data that's sent to one machine and other data that's sent to another machine. And what we would like to do is merge that data together in a way that is properly weighted, in a way that properly compares those two distributions, doesn't just kind of take the average of two, right? That's not an accurate way to kind of merge two distributions together. So this is something that's built in ylogs. Okay, so let's get out of the weeds there a little bit and move back up to thinking about these insurance AI use cases. One thing you might have noticed about many of those use cases, thinking about the inputs and the outputs, is that they vary quite a bit. I find that the insurance sector has a lot of different multimodal issues, right? So you may have PDFs of forms that are filled out, so image data, or pictures of damage, property damage. You may have text, lots of text, certainly. You may have tabular data. You may have time series data. There's so many different types of data, and you have to find tools that work across them. And so this is something that we recently in the last few years now, have really struggled with and come to a great solution for. And that is, how do we move from these summary statistics that you typically think of, numerical data, or maybe some categorical data, so like short answers, short text answers or something like this, onto document scale information, right? Like what sort of aggregate statistics can you do on a full document? And the solution is actually capturing semantically meaningful metrics on the text. So for example, here we have some text and we have entity recognition. So this is a common natural language processing technique to find kind of proper nouns, so people, dates, organizations, that sort of thing in the text. And maybe pulling those out, extracting those, or extracting just the count of those or distribution of types of those will give us some meaningful information about the text that can help us to diagnose what's happening in our system. And this is where Lan Kit comes in. So while ylogs is really about that complex statistical summarization and doing that in an efficient way that captures error and all of these things, Lan Kit is about coming up with new metrics that are semantically meaningful for text and LLMs. So for example, I think I have some questions here that you might have of the text that would be hard to answer without Lan Kit. So how were my prompts and response written to the LLM? Were they, for example, maybe too advanced? Maybe they have a really high reading score, or maybe they were quite negative in sentiment, this sort of thing. How were my prompts and responses, like, were they readable and accurate to their design intent? Does my LLM talk about or summarize thing that that we explicitly don't want it to? Especially in the insurance sector, right? There's lots of things where you are, if you have a chatbot scenario, you would be very hesitant to give specific pointed advice about certain things, or relinquish control to the LLM to do so. There's certain, legal advice, right, that we would not want to give. And so you really need to make sure that the text that is flowing out of your system, we can detect whether or not that's happening. The next category that's really important is security. So security, things like leaking sensitive information. So users may be passing sensitive information that you don't necessarily want in the chatbot context. But then also models are trained on lots of data that has lots of private information. And that information may be leaking back out from your model to users, and that's even worse. How are you able to detect jailbreak attempts? So these are attempts by users to type a question in there into your prompt to maybe get the system to do something that it shouldn't be able to do, right? Maybe you'll have users typing, fiercely, coming up with ways to try to trick your chatbot into giving some information about another user, or changing the status of your claim, or many other different things. So what are some example metrics for text that come out of this? So some are, I've already mentioned, things like text quality via readability score or complexity. Text relevance is very helpful. So in understanding the similarity between a prompt and a response, or the responses and some user-defined themes, help us to better estimate whether or not a LLM may be hallucinating, giving inaccurate information that sounds similar or not. May be helpful in detecting whether or not there is some sort of toxicity, that sort of thing. Many security and privacy features, so the jailbreaks that I've mentioned, refusals, different patterns and things that we don't want to see in our users, and we want to stop our system from passing this on to the LLM, or passing a response back in case that it is harmful. And then sentiment and toxicity, so understanding, how is the user being very, very negative or positive, right? Maybe some estimation of the mood there, and then toxicity, right? You don't want your chatbot to use toxic language back to your user either. That would be a terrible customer experience. Okay, and then I think this is my last best practice here that we're going to talk about today. And this is a pretty complex one. And this is about ground truth and bias. So one thing that we see is that in many sectors, but especially something like insurance, where there are processes that will kind of cause customers to drop out of the process. So for example, you initiate a claim, and maybe this particular claim is disqualified for some reason. And so then this is what I'll consider like a dropping out of this process. This happens many, many times in lots of data sets, but what it leads to is bias in the data. And the suggestion for this is so you may be able to collect training data or labels or eventual kind of resolution for only some subset of customers or situations. But this will prevent you from fully understanding how well your model works across kind of the whole spectrum of use cases. And so what you'll have to do is commit resources to balancing that labeled data. So this will be something like going and getting employees or crowd workers to analyze the text of chats that for claims that dropped out from the very beginning, right? To make sure that we're not missing any false negatives there. And then further, we can do some statistical things like weight the performance estimation to counteract some of this bias. So here's some pictures here just to kind of help us understand this. So for example, you may have phone contact and web contact, and you have a number of people drop out to this red section, none, and you have a number of other people who start some trial of some sort, and then go on to the next phase, and so on and so forth. So all of those people who have dropped out, you may not be collecting final data about them, right? Maybe at the subscription step here in this example is where you collect a bunch of demographic information. That means you don't have demographic information about a subset of those people. And it's probably not equally distributed, right? Like there's probably something about those situations that are different. And so we need to collect some data in that space. And this just fits into this larger problem of understanding not only your data as a whole, but thinking about segments of your data and how they relate. So how do we weigh performance across kind of different segments? This is actually a view into the observability platform. Okay, so I am pretty short on time here, which I suspected. So we'll quickly talk through the two use cases, and then we'll go look at a demo using one of the use cases. So one use case I want to talk about is generating text with question answering consumer chatbots. So here's our task. We'd like to generate answers for customer-submitted insurance questions using an LLM. The questions are intended to be generic questions that are answered without customer account information, just to make this a little simpler for us. So the sorts of questions a customer might have, or a potential customer may have, are things like, what exactly counts as this sort of claim, or something like this. This sort of query, or what exactly is this type of insurance even? So this is an input. This is a query from the user, and it is text, right? It can be a paragraph. It can be shorter than that. It can be longer than that. And the output is, again, text. So this is a chatbot. This is responding in text, or maybe some options to click. And these questions can be kind of individual. So you can think of maybe not a chatbot situation, but a knowledge center situation, or they can be conversational. So something like a chatbot. And you probably already have access to these sorts of conversations, especially if you are recording some sort of customer service rep interactions, right? I don't have those. So I'm using a really interesting data set that we'll see in our demo here, and that is from insurancelibrary.com. It is essentially just a knowledge resource center for insurance, kind of general insurance questions that has been downloaded and used for these sorts of explorations of models in the insurance space. So here's one example page. You see the question that was asked is, what are tax-sheltered annuities? And then there's some response that was given by a human. And we can use those responses to train our data, but in our case, kind of demo the system. Okay, and then since we're a little short on time, I want to show the second use case, but we'll dig into the first demo for our time. So the second one is legal entity extraction. So in this scenario, let's say the insurance company receives demand letters from the office of an attorney. And the letters themselves have various important details contained in the body of the text. So they may have the law firm, the insurance company, the policy number, the payout, required actions, et cetera, et cetera. And the input is a PDF image of a demand letter. So something like this, you see here this notice of representation, where addressed to a particular insurance company with a name and a letter that has a bunch of content inside of the letter itself, right? So it has names of the lawyer, it has insurance policy, it has policy amounts, it has all of this important information inside the body of the text. So it's very common that what you need to do is some sort of extraction of this information. So one way to do it is kind of entity recognition, grab all the names, grab all of the specific information that we want out. There's many other extraction techniques. But this example, since we won't get time to go to it, I do suggest looking at the AWS implementation of the model side of things. You won't get to see the monitoring side of things, which is where we come in and where it's very helpful. But let's go ahead and instead look back at our question answering task here. And now I'm going to switch over to a Colab notebook. The link is shared if you'd like to follow along. If not, that's okay too. Okay, so this is a Colab notebook here. I am first going to install two different tools. So one is Lan Kit, one is GDown, just to download some data from Google Drive. I've already done this here, and I think for time, I'll just run this just so we're all on the same page. Mine's going to run much faster because I've already downloaded it here. But we want to pip install. So one thing that I talked about is both ylogs and Lan Kit. Ylogs is also pip installable, but it is a dependency of Lan Kit. So if you're going to use Lan Kit, if you have LLMs and you have text data where you want to get these kind of semantically meaningful text metrics, then installing Lan Kit will give you both ylogs and Lan Kit. Okay. But first, we're going to start with ylogs. So now if we import ylogs as y here, the next thing that we can do is initiate our session. And I'm actually already initiated. I think what I want to do instead, I think I'm going to actually stop my runtime. So now we will have to download, just so that we see the same thing. Okay, now this is going to take a bit of time. So now we're downloading here. Let me walk you through what we're going to do since we're pretty short on time here. And then we can run it and see it in action after. So the first thing that we're going to do is I have an example of just some data from a LLM. So these are chats. So we're going to have a prompt and a response column of these chats, and we'll see that in a bit. What we can do with those chats, so I've actually downloaded some insurance-specific chats from that insurancelibrary.com. We're going to skip this for a little bit. So how do we get started with Lan Kit? So all you have to do to use Lan Kit is actually import a module from Lan Kit. So in this case is light metrics. It's a set of metrics that are helpful for text, but a lightweight version just to do this very quickly. And initiate those metrics. Sometimes the initiation takes a while because these metrics can be calculated with their own language models. And then we just log our data using the schema from these metrics. So I think we should be ready to run this. No, not quite. Let's see here. We'll give it a little bit of time. Okay, we'll just review here. So when we run y.log, what we're going to do is we're going to see a number of metrics being calculated, statistics being calculated on our text data. And I kind of regret downloading this so slowly. Hopefully we'll get a chance to see that. This download process, of course, happens once when you install it on your machine. I reset this so we can kind of see the same thing, but we're seeing something really slow. So let me just keep going, and then we'll actually run this at the end. So the way that Lan Kit works is we're actually augmenting the data that we have. So this case, text, maybe prompts and responses, with a number of additional metrics that we can calculate. And the metrics that we're going to calculate here are things like sentiment, toxicity, vocabulary metrics. So as far as readability scores, as far as kind of just counts of characters and words and length of words, that sort of thing. And we do that by applying these functions on this data and kind of expanding our data frame of information. Let's see if this is done though. Nope, still going. Downloading CUDA. From there, we can add custom metrics if we'd like. So this is a very, very simple custom metric, just to give you an example of how to do so. And then what we'll do is we'll see this monitored in Lan Kit. I'm going to actually go here, and because of this, oops, show you the monitor first. Let me log in. Okay, so this is the initial dashboard in YLab's platform. Everyone will have access to a demo organization that can be really helpful to seeing some examples of the LLMs. So in particular, let's look at this demo LLM chatbot. So this example is not an insurance example. We'll download the insurance data with the code when it loads, but let's go ahead and look at this. So we see here dashboards. Oh, and actually, let's go ahead and make sure we're looking at the right dates. So first, let's look at these profiles. I want to look at a particular range of data when this was downloaded. And you can start to see a couple of things. So one are insights about the data. So things like imbalance in the data, toxicity scores, and if there's a high toxicity score, alerting to that. There are a number of different metrics that are calculated. So things like reading level, character count, all of the stuff that I spoke about before. And there are many, many dashboards that can be helpful in understanding this data over time. So I'm going to go to dashboards here. And now we're looking at our security dashboard and seeing what sort of issues we may have. So has patterns is actually about different sort of patterns of likely data leakage. So things like social security numbers or things like this, which we likely don't want to see in either the prompts or the responses. Things like refusals. So whether or not our LLM has given a response to say, sorry, I can't answer that question for you or something like this. And depending on your application, you may expect to see a number of those or not. Toxicity, sentiment, all of these sorts of things. And you can also see, so here's our example in the response. We do see some patterns on this last day. We see 16 social security numbers, 16 email addresses, and 24 credit card numbers on our data, right? So a very large spike of these data leakage. And so we want to be careful and certainly kind of investigate the issue here. And we can see this in count as well, right? And a number of other issues that have come up. And then finally, well, two things here. So one, you can create monitors. So there's many different monitors that you'll want to create alerts for when these issues happen. So you can create a custom monitor, or look at our presets that already exist and apply them to your data. And then finally, this is a common view that we'll see. So this is the historical data that we, time series data that we see over time, along with alerts. So if I look at any of these, let's look at aggregate reading level here. We see that we have a monitor set. We may have multiple monitor set, but in our case, we have one. And it looks to have a static drift threshold here, something like 0.2. And we can see that we've gone over that drift threshold as measured by Hellinger distance. There's many different measurements that you can use, KL, we can use KS tests, we can use PSI, different ones. So yeah, this is a view that's really common and a kind of first place to investigate into issues into your data. Okay. I am going to leave this notebook for you to run. This is just the process of getting that data here. I've walked through it. Feel free to just kind of click through and see how data gets passed in. Since this is hopefully complete here. Oh, it's not even complete yet. I'll just note that when you initialize your ylogs, you'll want to pass in the API key or just hit 2 for a guest session to start to explore some of the features. And with that, I will go ahead and wrap up. So just a reminder here that ylogs is the open source tool that we have. Feel free to go to GitHub and download it and explore how to do this sketch-based data profiling and creating telemetry for your machine learning data. And then if you're working with LLM specifically, be sure to use Lan Kit as we've been using right now. And then finally, digging into the platform itself to see patterns over time, see much more advanced and much more actionable kind of insights from our data. And here are the links to be able to do all of those things. Thank you. And if you have any questions, please let me know.